Hello, algebra. Today we are moving to 4.3, solving systems of equations by elimination. And so if we're going to do elimination, our first step is going to be to rewrite the problem so that the variables are aligned. We want to do elimination, especially if it is in standard form. That's your ax plus by equal c. Our goal is to isolate a variable by canceling out one another or eliminating a variable and then substituting it to find the actual second variable. Remember, your solution must be an x, y coordinate, and then you can check. So let's look at number one. Do you remember back in the days when you used to add? So you would have 15 plus 12. Well, 22, because I have that now. You would add the ones column straight down first, and you would get 7. Then you would add the tens column straight down, and you would get 3. So you would have 37. Well, that's how we're going to approach the system if it's in that standard form. So I had the x under the y, the x on the x, and the y under the y, and it's equal to a number. When I line it up, do you see this negative 2y and positive 2y? Well, we know that a negative and a positive, they're going to cancel each other out. Negative 2 plus 2 is going to cancel out and give us 0. So then I can cancel that out. Now I would have 6x, and that's going to be equal to, so 5 plus 1, that's 6x, and negative 19 plus 1, because it's a positive 1, is going to give me negative 18. And then now it's a one-step equation. I would solve for x by dividing both sides by 6, and x is equal to negative 3. But the solution to a system, of course, comes with an x and a y. So then I would go ahead and substitute the x in to find y. Now, it doesn't matter which equation I use. I could use number 1 or I could use number 2. I'm going to go ahead and use the first one. Meh. So we have x minus 2y, and that's equal to negative 19. But I now know that x is negative 3. So negative 3 minus 2y is equal to negative 19. And now I'm going to solve this two-step equation. So I would add 3 to both sides. So that negative 2y is equal to 16, negative 16. And I divide both sides by negative 2, so that y is equal to positive 8. The solution to my system then is negative 3, 8. That is the solution to my system. That's my answer. All right, so now let's go ahead and substitute because we want to find out, am I correct? We can go ahead and check by putting it into both of them. So that, let's see. X minus 2y is equal to negative 19. So negative 3 plus 2 times, minus 2 times 8 should give me negative 19. So negative 3 minus 16 should give me negative 19, and that's true, so that's good. Then I would have 5x plus 2y, that's equal to 1. This is 5 times negative 3 plus 2 times 8, and that should be equal to 1. 5 times 3 is negative 15, plus 16 should equal 1, and lo and behold, yes, it does. I know I am okay. I'm good to go. You pause and try number 2. All right, now that you are back, When you look, you should see 3x plus 3y equals 15 and 2x minus 3y equals negative 5. If I look, my x's, they won't cancel out. I look at my y's up and down. I see a positive 3y and a negative 3y. That means they will cancel out. So I'm going to eliminate the y's. So now I have 3x and a positive 2x, so 3x plus 2x. That will give me 5x, and 15 minus 5, that's going to give me 10. So 5x is equal to 10. To find x, I would divide both sides by 5 so that my x is equal to 2. Now I want to find y, because again, every solution must come with an x and a y. So to find y, I pick an equation. I could pick the yellow equation, or I could pick this green equation. It doesn't matter. I can substitute this into any of them in order to find y. I'm going to pick the first one just because. So now I have 3x plus 3y, and that's equal to 15. X I now know is 2. So 3 times 2 plus 3 times y will equal 15. Now I'm going to go ahead and 3 times 2, I get 15. I'm going to subtract 6 on both sides so that 3y is equal to 9. And then I divide both sides by 3, and my y is equal to 3. So my solution to the system is 2, 3. Or at least I'm pretty sure it is. So then that is my answer. Let me write that there. Answer. So now I'm going to check. I've been checking in green. So I'm going to check both of those equations. My x is 2 and my y is 3. So 3 times 2 plus 3 times, oh, I should write the equation. 3 should equal 15. 6 plus 9 should equal 15. And that is true. Now I'm going to check the second one. 2x minus 3y is equal to negative 5. So 2 times 2 minus 3 times 3 should equal negative 5. 4 minus 9 should equal negative 5. And yes, that does equal negative 5. So I am good to go. I am correct. Now, this is nice and pretty, right? Number 1 and number 2, there's something beautiful I can cancel out. But we know that's not always the case. Because of that, sometimes we have to do some work. Sometimes we might have to manipulate one equation to be able to solve by elimination. So if I look here on number 3, I can eliminate something. So I have the first one and I have the second one. If I look up and down, I have x and x. Okay. I look at the y's. I have 4y and 4y. Numerically, that's pretty good. I want to cancel one of them out, but a positive 4y and a positive 4y gives me a positive 8y. So then I need to adjust the sign then of at least one of them. I can multiply. I'm going to go with the bottom one. Can you multiply the top one? Yes. It's going to depend. So I'm going to multiply both of them by negative 1 only because I need to change a sign. So when I do that, my yellow equation is going to turn to 2x, positive 2x, negative 4y, and it's equal to negative 8. So I like to, because there's a lot going on, I always like to rewrite my system so that now I have 3x plus 4y equals 18, and I have 2x minus 4y, and that's equal to negative 8. All I did was rewrite this yellow equation. and the green equation, the first equation, stayed the same. Now that I have that though, I should see that I can cancel the positive 4y and the negative y. So that now I have 5x, and that's equal to 10. 18 minus 8 is 10. Again, I'm doing old school, adding straight up and down. So now I would solve for x by dividing both sides by 5, and x is equal to 2. I'm not done because every coordinate must come with an x and a y. So I can use this equation, that equation, or even the original equation to be sure. Doesn't matter which one I use. We pick one. We have some choices here. So I'm going to go ahead and use the green one because that's been constant. And I'm going to substitute it into there. So that 3x plus 4y is equal to 18. I'm going to substitute 2 in for x plus 4y equals 18. And then I'm just going to solve. Two-step equation, I'm going to minus 6 on both sides because I want y alone. So that 4y is equal to 18 minus 6, which is 3 6 is 18, 2 6 is 12, 12. Then I'm going to divide both sides by 4 so that y is equal to 3. And this does take us back to chapter 1. We are still solving equations. My answer then is going to be 2, 3. Let's come on down to number 4. And in fact, I want you to pause, see which one you need to adjust. Using number 3 as your example, go ahead and try number 4. All right, now that you're back, let's see. We would have, this one's fancy. I have 2x plus y equals 3, and then I have negative x plus 3y equals negative 12. Now you're going to have some choices. Do you want the y's to be canceled out, or do you want the x's to be canceled out? Because I've been canceling out the y's, I'm just going to choose x. But then I want to think, if this is a 2x positive and this is a negative 1x, what would I have to multiply this bottom one by in order to make it cancel? You are correct. It would be 2. Positive 2 and negative 2, that's what cancels out. So I would then have to multiply the entire equation down here by 2. So that I get negative 2x plus 6y equals negative 24. And just remember, whatever you do to one to keep the equation balanced, you've got to do it to the other ones as well. Let me call this the green. We're going to call this the green one, and we're going to call this the yellow equation because that's what I've been doing. A lot of times this highlighter just decides it wants to have a mind of its own. Okay, so now let's go ahead and rewrite the system. And I know I'm working with 2x plus y equals 3. I didn't change that. But the second one I did change into negative 2x plus 6y, and that's equal to negative 24. This is still the yellow equation. It's just an equivalent form of that. And this is still the green equation. I didn't do anything with it. But now I can see that my 2's, my 2x and my negative 2x, they cancel out. Positive 2x and a negative 2x, they'll cancel out. So now I have y plus 6y, which is 7y, and that's equal to negative 24 plus 3, and that's negative 21. You know, I didn't check the other one. I hope you checked it. Then I'm going to go ahead and divide both sides by 7 so that y is equal to negative 3. Now that I know that y is equal to negative 3, I can use any of those 4 equations to find out what x is because they're all a part of the system. So I'm going to use the green one just because, again, the green one tends to be there all the time. So I'm going to go 2x plus y is equal to 3. And now I know y is negative 3. So 2x plus negative 3 is going to equal 3. 2x minus 3 then is equal to 3. Then I would add 3 to both sides. And 2x is equal to 6. And divide both sides by 2. So now x is equal to 3. So the solution to my system is 3, negative 3. And now I'm going to go ahead and check. So again, when I check, I know that the first one, 2x plus y is equal to 3. 2 times 3 then minus 3 should equal 3. 6 minus 3 is 3. Yes, the first one is good. Negative x plus 3y is equal to negative 12. I'm using the first yellow one. I could have done either, but this one is less. So negative x is 3, negative 3 plus 3 times negative 3 should equal negative 12. Negative 3 minus 9 should equal negative 12. And that is true. So I am good to go. Now, in the first one, it was already set. Easy for me to cancel out. In the second two, I had to work for it so that I can cancel it out. Sometimes we come down to like number 5 and number 6, and now I have to manipulate both equations before I'm able to solve by elimination. When I do this, I tend to find it easier to multiply both of them by their opposites, if that makes sense. So I see 7x minus 12y equals negative 22. 5x minus 8y equals negative 14. None of these match for me to cancel out. I also know, though, that graph in this might look crazy. I don't even have a graph. I also know that substitution might be rough because all of them have a coefficient. And so that everything is just going to be a sticky situation. I'm going to have to work for it. Because it's already like this in elimination form, I'm just going to mess with both of them so that they can be canceled out. So if I have 7x and 5x, I know I need it to cancel out. One needs to be positive, one needs to be negative, and they need to be the same number. So what I like to do is to multiply them. So I know that this by the opposite coefficient. If this is 7 and this is 5, I'm going to multiply this top, let me get a color here, by 5, because that's the coefficient of the second one. 5 times 7 is going to equal 7 times 5. Then I come down to the bottom, and I am going to multiply it by 7. See that number there? And that number there? I am going to multiply them by those numbers. But I do know that they need to cancel out. So not only that, but one of them needs to be a negative version. Does it matter which one? No. That's going to be up to you to pick. So now you're really using your noggins and thinking about how you want to apply it. Either way, I'm going to have a new set of system. If I multiply this by 5, that becomes 35x. 5 times 12 is going to give me negative 60y. And 22 times 5 is going to give me negative 110. Then my second one, I'm going to go ahead and multiply that by the negative 7. So that my new equation is negative 35x. Negative times the negative is a positive. So positive 56y. And that's going to be equal to negative 7 times negative 14. Oh, that one I don't want to work out. And that one's going to give me positive 98. It's a negative 7 that I multiplied on the bottom. So now we should see how the first green equation has been manipulated and the yellow equation at the bottom has been manipulated. I have adjusted both of them to cause the x's to be canceled out. Could you manipulate them to cancel out the y? Yes. This is always your option. Miss Reed likes less work, so I will use the lower coefficient more than the higher numbered coefficient. So then I would still go as I did before, negative 60y plus 56y, and that's going to give me negative 4y, and that's equal to negative 110 plus 98, which is negative 12. And then I divide both sides by negative 4. That's the one-step equation. And y is equal to 3. Now that I found y, I need to find x. All right, this yellow matches. And this green matches. Their equivalent equation, the yellow, and the green. So either way, now that I found the y, I need to find the x. To find the x, I can use that equation. I could use this equation. I could use that equation, or I could use that equation. Any of the 4 equations will work. I'm going to go ahead because I like small numbers. I'm going to pick my original green equation. That's this one. And so I would have 7x minus 12y, and it's equal to negative 22. Y I know is equal to 3, so 7x minus 12 times 3 is going to equal negative 22. 7x minus 36 is equal to negative 22. This is now a two-step equation. This is a review of chapter 1. So I add 36 to both sides, and 7x is equal to, I don't know, which is 14. And 7, divide both sides by 7, and your x is equal to 2. So now I know that my solution to this system is 2, 3. That's the coordinate. All right, so now, of course, we want to go ahead and check this work. Maybe something happened. You should know before you turn anything in if you are correct or not. And so we would have, okay, let's do this quick. 7x minus 12y is equal to negative 22. 7 times 2 is equal to, minus 12 times 3 is equal to negative 22. 14 minus 36 equals negative 22, and that is true. For the next one, 5x minus 8y equals negative 14. So 5 times 2 minus 8 times 3 is equal to negative 14. Again, I am using the solution because you could always check the system. by substituting the solution. So now we have 10 minus 24 equals negative 14. And yep, that's true. I am done. I knew for a fact my answer is 2, 3. I want you to pause now and try out number 6. I know it's a little bit rough, but pause and try out number 6. All right, now that we are back, we should have, and you could have done either actually. I chose to multiply the top by 3 and the bottom by 2 to get my equivalent equations. You could have multiplied the top by 4 and the bottom by 5 because your signs were already ready to be canceled out. Either one you did, this is my equivalent equation, and I would have gotten y equals 4. Then I picked any one of the 4. I chose the third one, and I got x equals 3. And then my solution then was 3, 4. I checked my work, and I am good. Um, I will see you next class. But remember, to learn mathematics, we must do mathematics.